Hello and welcome to this Simpleware webinar. Thank you for taking your time out to join us today on this topic of accelerating CMF/orthopedic segmentation and image processing with Simpleware AI Solutions. We'll soon get started with the presentation. Hopefully everyone's joining okay with the GoToWebinar system today. Firstly, just to maybe start with the introductions. So I'll introduce myself first and then I'll hand over to my colleague Karim Genç, who will introduce himself and take us through the first half of the presentation today. So my name is Ross Cotton. I'm the Applications Engineering Manager for the Simpleware product team at Synopsys. I look after a team of application engineers who oversee the technical support and consultancy projects for the software. And yeah, I'll pass on to Karim.
Hi, everyone. Thank you for coming. I appreciate you spending some time with us. My name is Karim Genç. I am the product manager for the Simpleware team, and I am based here in Seattle, Washington. So I guess with that, we'll get started on this webinar today, talking about accelerating CMF and orthopedic segmentation and image processing with Simpleware AI Solutions. Let's get this going. There we go. So just some logistics here with the GoToWebinar. Actually, this is not a recorded presentation, but a live presentation with a live Q&A. The attendees will be muted throughout. You can submit your questions for the Q&A on the right here. We'll try and get through as many as possible when we can, Ross and I. And if we can't get to your questions, we'll follow up with an email afterwards. And this webinar is being recorded, so it will be made available afterwards. So just to give you a little bit of background of Synopsys, it's a company that's been around for 35 years in the chip and semiconductor industry, based out of Sunnyvale, California. And as you can see, it's quite a successful and growing company over the past decade at least, with closing in on $6 billion in revenue, about 20,000 employees, lots of patents and offices globally. And in the area of chip and electronic design and automation tools and services, Synopsys is the gold standard, with a very broad IP portfolio and really a leader in its industry. And that brings it down to us. We're the Simpleware product group. We were acquired by Synopsys back in 2016, and it's been a really nice environment to be part of, to grow and accelerate our technology, as we'll showcase here today. We develop high-end 3D image processing software and solutions. So the high-end view is we go from 3D images to models. That's the space we play in. That's what we're very good at. We have dedicated sales, support, and services teams globally, and we work with customers from clinical to life sciences, materials manufacturing, many different industries, but primarily within the life sciences and medical applications. So in terms of the flow and the workflow that we work with is with medical 3D images. So it's a medical 3D image-based modeling workflow. We on the left here, you'll see this gray arrow. That's where the Simpleware software sits. So on the left, you can see you can import image data. So this is from CT or MRI data, computed tomography or magnetic resonance imaging modalities of, I'm sure most people attending this webinar have had an MRI or a CT scan done on them. And this is the data that we import into Simpleware. You can do your segmentation, you can generate your models, and then do some analysis and reporting within the software. It's an off-the-shelf software with traditional licensing, and from there you can export into models that can be used for us. It's focused on three main areas: implants, guides, and surgical planning, point of care 3D printing, and in silico clinical trials, and other ways of leveraging simulation for things like medical device design and regulatory clearances. So yeah, our clients consider us a best-in-class tool for image segmentation, AI-enabled automation, analysis, reporting. We can fully customize it with our scripting, our GUI, our different AI algorithms, and the standard exports of STL, 3MF, CAD, and simulation exports allow us to cover varied contexts of use within these three main markets. So Simpleware Scan IP Medical, that's our flagship image processing platform or software. It's CE marked and FDA 510K cleared. We have, if you go to our website and our regulatory page, we are ISO cleared and are ISO certified, and have clearances for Various 3D printers and their materials for different applications were used in hospitals that are doing point of care 3D printing, as well as other types of image-based or patient-specific personalized medicine. What does Simpleware do? So our off-the-shelf software that we license and have Simpleware users within academia, government, and commercial companies is you can import. So going kind of from the left to the right of this graphic, on the left you'll see you can do 3D or 4D image import and visualization. So you can import that image data, visualize it, do volume rendering, cut at different angles, and be the first step to inspect your image data. And then from there, you can do a process called segmentation. So this is where you look at the grayscale values of the different geometries and use different tools from fully manual to semi-automated to automated tools to pull out and segment the geometries. Some people call it labeling. So there's different terms used for that process. Then from there, you can do some measurements and analysis, things like center lines, cross-sectional areas, volume, all sorts of different types of Booleans and applications of looking at the geometry and doing different types of measurements, a whole host of tools within that. You can also import CAD geometry. So if you want to import a medical device, position it, and things like that, you can do that. Cleaning up STLs, all that kind of stuff you can do. And then you generate your model, whether that's a surface STL, 3MF, or a NURBS parametric surface, or a full volumetric finite element mesh ready to go in tools like ANSYS and Abacus and COMSOL and things like that. So we have different applications, different types of multi-physics, mechanical, fluid, electromagnetic, or combinations for people using us on the simulation space. And then we have scripting and automation. So this is where you can leverage different levels of automation, which I'll get into, to automate workflows. So people typically what they'll do is, if it's a medical device company, they'll bring on Simpleware to start processing image data to do patient-specific workflows. And from there, as the company grows, we like to grow with them, and help support that growth. And for companies to grow, segmentation and image processing tends to be a bottleneck. And we have tools and automation capabilities, everything from off the shelf to fully customized solutions to help people scale that workflow, to go from say, 2 patients a month to hundreds or thousands per month. And we have that spectrum of capability, and we have those long-term relationships and that long-term view in building these relationships with our customers. And also we can package these and deliver these automated tools under the hood, white label them for other people's third-party applications. So we're very open and flexible in how we bring this technology to market. So the first level of automation is scripting, Python and C# scripting API. So anything you can click, you can script within the software. So the different things you have your API where you can write your script. There's the macro record where you can click through your workflow, hit record, click through your workflow, hit record again, and it'll spit out the code. You can convert from the log file. So everything you do is recorded for traceability within the software, just as standard. So you can go to that, leverage that traceability, highlight the area you want, and convert that into script. You can build plugins within the software, and then we have customers who come to us, and who want specific things customized. So, if it takes us, half a day, we'll just do it for our customers, send them the code. But if there's other cases where we have to dedicate an engineer for a week or two to build something, we can do that as well. So the second level of automation is our off-the-shelf machine learning-based AI tools. So this is AI-enabled segmentation and landmarking. So this we can automatically segment your geometry of interest and do the landmarking. So we have 2 tools for this. One is called AS Ortho CMF. So this is automatic segmentation and landmarking for the ankle, knee, hip, shoulder, and CMF, Cranio-Maxillofacial for CT. And then we also do knee MRI And you can see examples on the right here of the different anatomies where this is applied, and you can see all the landmarks that are automatically picked off and labeled. And so with the landmarks, you get free measurements, just a little bit of script, and you can take different measurements, define planes, define cutting planes, things like that. And then we also have AS Cardio. So that's for automatic segmentation and landmarking for 3D and 4D data of the heart from CT. And we have some pretty impressive capabilities there. Recently, we did a nice 4D beating heart from Nicholas Children's that, it was 20 time points along the heart's beating, the heart cycle from diastole to systole. And manually, it would take a person a day and a half to do each time point. And there's 20 of them. So you can imagine how much time it would take. And we were able to speed that up, write some scripts, and to have stuff that's going to be in the software soon, where we can bring that down to a day to do 20 cycles of segmenting the heart and the blood vessels. So we posted that on LinkedIn. If ever anybody missed that or is interested in it, please reach out. I'd be happy to share it with you. So these are the off-the-shelf tools, and these are just added on to our base software. So these can be licensed tomorrow and just applied right away. And today, Ross will be giving a bit of a demo, a focus on the CMF applications. This is our latest one that we released, and how that works. Our third level of automation, this is when just say AS Ortho or AS Cardio is not quite enough, not quite what you need for your workflow. So you need a different anatomy, or you want more landmarks or something more specific, or if your data sets have a lot of noise, a lot of osteopenia, osteophytes, things like that need to be accounted for in your automated tool. So that's where we get to custom modeler, is what we call it. So this is automated segmentation landmarking of any anatomy and any imaging modality, and we can integrate this into Custom Modeler as an add-on module, or we can even OEM these capabilities and white label them for others to use. So the ground truth data is either provided by the customer, or we can source it, and this is developed, when we engage with the customer, their data is their IP. So when we build something, it is specifically for them and them alone. And so Simpleware is kind of the secret sauce for quite a few customers out there. Unfortunately, with that, it's nice to be considered the secret sauce, but the secret part makes it a little challenging when you want to talk about it. But with Corin, they're a company we've been working with for over a decade, and their OPS system, the optimized positioning system. So with them, they're actually now they're probably up to 600 or 700 knee, ankle, and hip CTs processed per month into their workflow. And we reduced the time, so when they worked with us initially, they were using Simpleware, then they started scaling up the number of licensing, even use some of our services, started building it up, then writing scripts to automate it. But then when we deployed the AI tool, we were able to drastically reduce their time for segmentation by 94%. And then another orthopedic device OEM that we work with, they processed about 5,000 scans within the first 3 months. And they went from 30+ minutes per scan to down below 5. So, saving 25 minutes for a model is not a huge deal if you're dealing with 1 or 2 per month, but when you're talking 60 cases a day, that's a huge time savings. And also it ensures accuracy and reliability of results, and it just kind of takes the human error out of the loop with these applications. So just to recap on these different levels of automation. So the level of automation really depends on the target application and the level of the current anticipated scale. So we work with our customers, as I said, typically they start off with the software and start building their workflow and then come to us when they want to scale. Other times we come into a customer who is throwing, they're hiring technicians, hiring engineers to do the manual work, and we come in to offer solutions to automate that process. And these are long-term relationships. We want to enable our customers to grow and scale long-term, and we work with them for that. So this little table here, I kind of call it the spectrum of automation, from manual on the left to fully automated on the right. So you can see the number of, on the left column is the number of data sets per year and time savings. So the first column is Simpleware Scan IP Medical. So this is the standard approach, kind of the baseline. And typically people will have maybe 1 to 100 models per year that they're working on in terms of the numbers of models that they need to have in throughput. And then the first level of automation was scripting in Python. That's a little bit more models. They can save, it's a pretty wide range of time savings depending on the workflow. Then you get even farther, the off-the-shelf auto segmenters that I talked about, AS Ortho, CMF, and AS Cardio. This is where you could be dealing with hundreds potentially of data sets per month, where you'll still have some cleanup potentially because it's trained off of different data sets than what's being applied to. But depending on the workflow, it can save you quite a bit of time. And then we get to custom modeler, and that's when you get hundreds or thousands of data sets and really need something to have high throughput. And the key with us is we can deploy it quickly. Once we get the data, it takes about 90 days to deploy a solution. So it's fast, it's accurate, and we have a lot of experience doing it. And Ross and his team are pretty impressive with it. So I'll get into some examples, just to point, two or three examples here. One is point of care 3D printing example. This is anatomical 3D printing within a hospital. So this is with Nicholas Children's. So they had a patient with a heart defect, and they wanted to do some segmentation and develop some 3D printing tools or some 3D prints from there. So we were able to bring it in, segment it within AS Cardio. It saved a significant amount of time. And then within our 3D printing toolkit, which is all built into the same software, you can build the mounts, you can do supports, get your model ready for 3D printing, all within one software. You don't have to export it and do it in another software. It's all within one environment. So this was the 3D printed model here. So the manual workflow would have taken them about 2 hours, but with Simpleware, it took them 15 minutes. So a significant time savings. They had Simpleware AS Cardio, the connectors, they did the debossing for the text, and the cylinder primitive as kind of the base support. And a little quote from the engineer at Nicholas, Tom Hanglid. Our new engineer segmented it. Well, he hit the go button on AS Cardio and then added the base and supports very quick. So it's exactly the type of feedback we'd love to hear from our customers, helping them to automate this workflow and help their patients. So getting into more the implants, guides, and surgical planning, where we can scale up to serve thousands of patients. This is with Corin, as I mentioned before, the optimized positioning system. It's a process of planning the position of implants for each patient to optimize functional implant alignment and improve surgical outcomes. So they avoid impingement and things like that. So they currently process about 600 patients per month. So it's the doctor gets the patient imaging, they send it to Corin, their OPS analysis team does the segmentation and several other processes within Simpleware that are proprietary to them. And then from there, they design the surgical cutting guides, the surgical plan, and then they deliver the device, the plan, the guides to the surgeon to implant. So they're, I think it was a year ago, they passed 60,000 patients. So they're well beyond that by now. So they've been processing a lot of patients with this process. And then just to show you how we deployed it real quick is we deployed the AI ML custom modeler solution to their workflow to automate it. And so in version 1, we had about 100 ground truth data sets, and we were able to reduce their time by about 80%. And then in version 2, when they realized, oh, there's other data that's coming across their plate, we pulled that in and we retrained it, and we were able to bring it down by 94%. So you can see on that table on the right there, the first one, 100% is manual off-the-shelf workflow. That 35% is with the scripting. So they did do scripting for several years to build that up. But then once we deployed the AI solutions, I mean, it was a no-brainer of how much quicker it is. And even that 6% there, a third of that is compute time. So it isn't even engineering time that's being used to process this data. So it's significantly saving them a lot of money. Their engineers are happier because nobody likes segmentation. So. And then we did a recent webinar with Topology on patient-specific guide design and automating that process. So we did this for 50 tibias, and we were just able to automate that. And they have some automation capabilities within their design flow as well. So that was a nice little webinar that we did not too long ago. So one other thing to mention too that I want to, before I pass it off to Ross, who's going to show you, give you a little demo, is the Simpleware University Bundle. So the idea here is to inspire and foster the world's next generation of technologists and innovators. We really wanted to invest in academia as a partner and to really help grow this area. So the problem is converting 3D images into models for academic research requires sophisticated software and well-trained students proficient in said software. So You know, I was a grad student. We had a license of Simpleware, and we played musical chairs on the one computer where we could afford a license. So I'm sure plenty of people have dealt with that. So because there's complex licensing and high cost, it limits researchers' access to software and their ability to conduct research and train students. So it's a real limitation. So the solution is to consolidate all Simpleware academic products into a single, very low-cost bundle to reduce the barriers of access. So we've offered 50 full floating network academic licenses of Simpleware, so there's no technical size limits, and it's for $1,500 a year. So this is a very low-cost way for people to get access to a lot of licensing and just open up that floodgate to allow students to get access, to teach students to use it. And this includes our AI auto segmentation, our AS Ortho and AS Cardio tools. This includes everything. So the idea is to enable campus-wide access for enhanced collaboration and teaching. And this is currently available for the Americas, Europe, Middle East, and Africa. We are looking at APAC and trying to expand it as there, but that's to be determined currently. And the one limitation, which should be rectified soon, is 2 of the modules, the CAD, for those of you familiar with Simpleware, the CAD and NERVS module are not included in the university bundle. That will be included soon. So keep an eye out for that as well. But we already have a lot of academics who are very happy about this, and we've deployed a lot of licenses to get them going. So we're pretty excited about this. So with that, I'll pass it off to Ross, and he can demo the software.
Thank you, Karim. Just while I'm getting ready, just a little reminder on the questions. So if you've got any questions from what you've seen so far, or if you think about any during the demo as well, please do submit those into the toolbox in the GoToWebinar system. So just make myself the presenter. Okay. Should be coming through. Is that okay, Karim?
Yep, looks good.
Great. Okay, so got just I guess with these demos with the AI tools, they're probably some of the easiest demos we could do as application engineers, because as you probably saw in the Nicholas George's Hospital one, a lot of the time you just press go and it gives you the results. So you won't see too much of kind of interaction with the tools today. It's just kind of showing you kind of where to press go and what it looks like and what you might have to do afterwards, maybe highlighting some of the other features along the way. So if you're not familiar with the software, this is what it typically looks like. Ribbon-based design, your kind of traditional 3 orthogonal views of the CT scan we've got here of this CMF case. And the bottom right, we have our 3D view, which currently has a volume render in, which you can do various things like use some of our presets just to change the rendering, so you can get some pretty nice screenshots just with that option there. In terms of finding tools, so they're all kind of labeled by group. So obviously image processing contains a lot of our standard traditional techniques for segmenting images. So kind of your manual painting all the way up to your automated, semi-automated kind of flood fill, thresholding, and other region growing techniques here as well. So what we're going to do is look at the auto segmentation, because that's the topic of today. So a separate tab, because they're quite valuable and nice to see in a separate area. AS Ortho is the orthopedic group. AS Cardio is this group here. Grim highlighted all these tools in the slides. So if you want to see some outputs of those, you can refer back to that original slide. But today we're going to look at the CMF case, and we're going to click and open it up. I'll just make it a little bigger because I've reduced my screen size for the demo today. And we have, for each of these tools, we have a selector diagram. So I'll just get rid of that for now. So for like the hip, for example, you will get a similar one, shoulder, CMF, heart, all have their individual selector diagrams to help you set up the AI inference. So it's a pretty simple user interface to get going. The input is going to be your active background, your DICOM file you've just imported. So we can see that in the screen here with the various cross sections in each of the different views. So it's pretty standard. Region of interest. Best just leave it as automatic. It will automatically find and detect the CMF region. Again, the same with like the hip one, for example. So if you have a larger extent in Z, for example, it will localize that before the inference and cut down the processing time. So you can change it if you want to localize it, or to minimize it further, but generally this will find it and reduce the processing time. So the selector diagram, you can turn parts on and off, gives you an idea of what you're going to get out of it. And the CMF, you can see all the various parts, and we'll go through this in the output I've got pre-prepared. At the bottom, we have our additional options. So we have, first one is create landmarks. So not just segmentation, we do produce some fairly standard landmarks for each of the anatomies. You can see roughly where they're going to be placed by these crosshairs on the selector diagram. Again, we'll show that during the example output. Keeple bone fragments. Again, I've got an example of this later on, but this is really helpful if you've got like a trauma case and each of the bones or a bone has been fractured and it's in different parts. So this option will enable you to make sure that's kept, and in most cases, when you don't have it on, it will remove all the floating islands that aren't associated with the main bulk of the bone. Unique to CMF, split teeth. So what we'll see with the teeth is that we'll split it into the molars and incisors and canines, but you can turn that off if you want to. So it just shows again some of the perhaps the AI technology we have that we can split up the teeth into various groups. So yeah, that's what the diagram is, and you hit apply and it'll go off processing. I processed it earlier on my laptop. My laptop's about 1-2 years old. It's a standard Dell laptop with a NVIDIA GPU in. I think the VRAM is about 4 gigabytes. Processing time, I think, was somewhere between 5 and 10 minutes. I didn't measure it exactly, but this is on one of the larger models we have. So some of the knee one, for example, I think is about a minute or so. So it just depends on the number of parts and the volume you're looking at. And obviously the CMF one is quite a large one in this case. So yeah, 5-10 minutes later, you'll get your output, and I've got something pre-prepared to show that. So if I just drag this one away, and you should see this is actually at the end of processing. So it's kind of a nice way of showing you that I've not tinkered with it at all or kind of edited it in any way. So this is the confirmation dialog. So it'll go away processing, you'll see a progress bar, and it will get to this point. And you get a nice kind of summary breakdown of what's been identified. So it gives you some confidence about what to expect from the inference here. Also in the landmarks, so it tells you where to find the landmarks. So if you go into the measurements tab, which is at the top here, you can go to quick measurements and then measurements. It will make more sense when I show it later on. But you can see, again, it's identified all those in this case, whether it's left, right, as well. You can click OK to dismiss that. And then we can look at our object list. So the dataset browser in the software contains the background images, so your DICOM file, and then all of your segmented masks. And then depending on what you do with it, you might go into creating some surface objects towards sort of 3D printing workflows or volume meshes for finite element analysis. In terms of the masks, we've got all of them here. They've all got preset colors, pre-named, and so on. I'm just going to set up the screen slightly differently. So I'm going to the View tab and doing kind of a 2D split screen for now. I'm going to use something called Live 3D. And this will automatically show the segmented masks. So you can kind of see the outlines. I've turned off the interior hatching on these just to show you the outside contours, but they're all represented here. Again, this is all customizable. Say if you wanted it to be translucent, for example, you can turn that option on as well. Maybe make that the central view as well. So you can see all those segmented labels. I tend to have it off most of the time just for clarity. But again, that's a personal preference. So in terms of the output, this is the raw output. So no editing is done. Just to confirm that again. This is what you'll get out straight away. This is a very typical result from a reasonably good CT scan. I think it does have some metal in the teeth as well. But maybe to get started, I think one of the highlights of the tool is you get 2 versions of the cranium we'll look at first. So this is the cranium default. It's kind of what you get if you say with threshold the CT data. So you can see the very thin bone here within the orbitals is or the orbital floor is kind of partially missing. That's usually kind of what you expect when you do a sort of a general thresholding. So what we've done with the technology we have, we've actually trained a model to predict the filling of these bone orbitals. So filling these, I know, is a very tedious task. You're either kind of using manual tools or trying to fill it in with various local filters, and it can be quite tricky to fill in just that area. So we're just zooming here. We've actually got another mask we can use now. So this mask is, again, an output automatically. It's called cranium-filled orbitals. If I just turn that on, you'll see now how that's updated the orbital mask. Maybe look on the left-hand side here. I'll turn it off and on again. So that's the kind of what you'd normally get with a threshold, and this is what you get with the orbital mask, orbital filling mask. So this is going to be a huge time saver if you're looking to do any work around the eye socket, reconstruct that area, design devices off that area. You're not going to need to go in and paint these regions manually. So that's a really, really big time saver. And just maybe just for comparison purposes, I can just change the color, maybe just into red, and you can see how that difference there between the two and how that's filled just that local region. So it's a very localized filling technique. Change that back. So we'll continue on. So the mandible, obviously that's the next one. Again, we're not seeing the teeth just yet, but there we go. There's the mandible split from the cranium. Spine at the back. It's pretty simple. And then we can look at the teeth. So for the teeth, I will just turn off the mandible for now. And we can look at adding in all the groups here. And you can see they're split by both upper, lower, molars, incisors, and canines. So they're all kind of groups. Again, you could group these if you wanted in the settings up front. But they're all set there, and you can also turn them off, say, molars lower. You get all the roots as well, separated out. I guess the rest of it, maybe let's have a look at the cranium. So we do some soft tissues. So we fill the cranium, we automatically or intelligently cut it off as well, just at the base of the skull. But you kind of get the imprint of the cranium. Again, might be useful. Again, you could turn it off if you want to at the start. We also have the mandibular nerves. So this is sometimes useful. It will give you the mask for the start of the mandibular nerves. Depends on the visibility of these in the data. Sometimes you get quite a nice extent. Sometimes it's like this. So if it can pick it out, it will. It will give you a good starting point, at least, for identifying the mandibular nerves. And just for a bit of fun, almost, we've added in some other soft tissues. So the eyes and optic nerves from the data. So we'll just find those in the CT as well. There we go. So you can see they're barely visible, but we decided just to try this out and add it as a feature. Kind of highlights what we can do with some of the soft tissues from CT scans as well. The last two, so ear canals, again, just isolating those from the CT. And you can see that blue mask there. Maybe more, looking at the ear region. And then finally, the airways. So you can get all the airways separated out of the nasal region and mouth if it's present, for example. And that's all there separated out as well. And again, it's all disconnected intelligently, so you're not having to disconnect it from the air around the subject. So that's all pretty straightforward. Again, if you need to edit these, these are all standard masks. You can just go in and use some of the 3D editing or any other of the tools we have to fine tune it and make it to the final version you need. But obviously, a lot of the time it just works as is. I just wanted to highlight something quickly in the CMF. We can also segment out the skin mask as well. But if we turn this on, we do get a kind of patient identification warning here that segmenting the skin can lead to patient identification by facial recognition. So this is an optional one. We don't have it on by default, but you can add that on. And yeah, just in terms of privacy, you can have it off as well. The next one I want to look at quickly is the second one I have here. That's the one I need. Just bring that back onto the page. This one's slightly different. This one has nice, but unfortunately, I think a tumor in this region of the mandible. Maybe again, just to highlight, the ones we're showing here are excluded from the training, so they're not being part of the training, AI training for this product. So in this one, I've used that what we call the keepable bone fragments, and that will show here. So if we look at the mandible, let's isolate that, Live 3D. So in this case, it's a really good example that it's kept both or all bone fragments that it could extract from this image. So you don't have to recreate half of that. Again, the teeth come out pretty well in this one, even with that abnormality. So I'll just bring those in this case. Okay, I think that's all it's going to show. Actually, sorry, one more thing. I was going to show some of the landmarks. Sorry. Let's bring in all the bone parts in this one. That's that. So the landmarks, if you go to the measurements and then measurements, they're all pre-named and positioned in here. So you have a quite extensive list. You can find them. They're all kind of locked for now, but you can go in and edit these. For example, if the mandibular symphysis is not quite in the right place, you can select it either in the list or here. You can hit the top of the lock, so you can move it, and then you can just reposition it wherever needed, and then lock it again. And from here, you can do all sorts of measurements. You can fit planes, create further measurements, push these. I mean, for example, with our design link module. So if you're running in sync with SolidWorks, you can push and pull segmentation and measurements between SolidWorks as well, which you'll find more information on our website. With that, I'll finish up the demo there and pass back to Karim for the final slide.
Thanks, Ross. Let me just figure out how to share my screen here. Sorry about that.
I'll make you the presenter again, I think.
Yeah, thank you.
There we go.
All right. There we go. So yeah, basically, I wonder if I can get this up. There we go. So yeah, thanks Ross for the demo. For people who want to see and try it, you can get a free 30-day trial from our website. We can do personal software demonstrations. We have all sorts of videos. And if you're interested within this tool, if you're interested in the Simpleware University bundle, if you think that's valuable for your academic group, again, all the tools Ross showed, that's in the bundle as well. So please contact us. We'd be happy to chat and see if we can help you improve your workflows with some of our AI tools. So with that, I will thank you, and we'll leave it open to some Q&A. Ross, have we got any questions?
Yeah, it looks like we've got a couple coming in. Maybe let's have a look. Yes, the first question we have here, it just says error rate question mark. I think that came in during the AS Ortho slide you were presenting, Karim, or maybe the custom model ones. I guess in terms of error rate, or maybe I'll have a quick go at it first. I guess error rate, it depends what in the custom one is. It depends on what you define as an error rate. And usually when we work on the customization, we work up front to define acceptance criteria and what would be acceptable as a kind of clean pass through without any editing. I guess we don't really have errors with the AI. It always produces an output of some sort. Obviously, it depends on, with the AS ones, it depends on the similarity to the data we trained it on, which hopefully we've tried to be as broad as possible, but maybe not too specific on individual pathology. So try to be as broad as possible. So it won't kind of fail. It will just maybe not perform quite as well if it doesn't match the input data.
Yeah.
I don't know. You want to mention anything?
Yeah. The way we like to position our off-the-shelf tools is they're segmentation aids. This isn't we're definitely not saying, oh, this is the easy button, you click this and everything's done. It's like running a threshold. You wouldn't just do a threshold and assume that that's correct. You do need to inspect it and make sure it's correct, because there is no CAD geometry from the patient from which to compare to. So it's all depends on an expert review of the data. So we're careful to say with the off-the-shelf tools, it can get you anywhere from, not, if you have a patient with huge pathologies and it just will not process it. It'll give you an output, but it might be completely wrong. To, in some cases it gets you 99% of the way there, 100% of the way there, where you just click once and it works perfectly. Obviously for the demo purposes, the data we had was ideal, but it can range, it can vary. Where we get into people who want something that is, single click, that's when we get into the custom solutions. And where the customer who is getting the data, they need to understand. Well, we work with them. It's always a process. It's a learning process in this for customers. Even they've been doing this for years, but they still might not completely understand the data that they're getting and how that can be implemented within an AI tool. And making sure it's the same old saying: garbage in, garbage out. You need to make sure the gold standard training data sets that you use are accurate and reviewed by an expert. We have clinical collaborators who can do that. Usually our customers, they can review the ground truth data sets to make sure those are correct. And then we can use those in the training. So, we've developed tools for specific customers where they're getting a lot of revisions, a lot of noise, a lot of osteophytes, things like that. And if that data is correctly segmented and included in the ground truth and trained, it can be deployed correctly. And you can have, in some cases, a single click solution. But you're always going to have a human in the loop to review it. And the advantage that we have is we're built on top of Simpleware, which has been a 20-year process of building this segmentation tool. So if any kind of cleanup or anything needs to be done, it can be done on an FDA cleared software. So that's how we deal with errors. It's it's not a good response because nobody likes hearing it depends, but it depends.
So
I hope that answered your question. That was a long-winded answer for a really short question.
We have got quite a few more coming in, so we might have to kind of provide some snappy responses. So starting at the top, how to get hold of the academic package, and does it include NURBS, are two questions.
Yeah, so you contact us, Simpleware at synopsys.com, and we can put you in touch. Simon is our academic account manager. It currently does not include NURBS. Hopefully that will be resolved shortly. So for customers who need that, we do offer, you can get our typical academic software package. That's no problem. So you can get access to it. It isn't 50 licenses for $1,500 per year. But we've been doing some short-term licensing to get people to that gap for when we eventually do release it. Yeah.
Good. Thanks, Karim. Is the MRI relaxometry for 2T mapping of the cartilage available within the software? Yes. If you look at I'll try and answer it high level. The MRI knee has a T2, T1, and PD weighted scan capability, so it will be set up to extract cartilage on the tibia and femur as shown right there. Thank you. Best bet is just to try it if you'll get an answer pretty quickly with the free trial.
Yeah, typically people, they start off with our off-the-shelf stuff, and they're like, yeah, this works pretty good, but I want this, and that. And then we get into custom modeler.
So next one, our third level automation solutions, so that's kind of custom modeler, available to any customers, including university research centers. In addition, can these large data sets remain anonymized while creating custom AI solutions?
Yeah, so first, we don't accept anything but anonymized data sets for any of the training with any of our customers. We make sure it's completely scrubbed before it's even sent to us. And yeah, I just posted something recently. A group at Yale got a grant, and we're deploying a solution for them, looking actually at brain tumors, which is a little outside of what we typically do, but the tools work great. And it all just depends. They have very good researchers who have a good understanding of images, and they have very good image data to build from. And we've been working with them. So yeah, definitely if you're an academic group and you're interested in something like Custom Modeler, let us know. We're definitely interested to work with you. And we like it more because it's typically public. They want to publish so we can actually talk about it.
Next question, does the hip CT including the SI joint for realistic joint spaces? Yeah, the hip CT in the AS Ortho tool does split the pelvis and sacrum, like you can see here. If there's a gap, it will preserve the gap. Again, the best thing to do is try it yourself and see how it works. But yeah, it should preserve gaps. So that's quite a fun question. Want to try this with the head of a rhino CT scan? Yes.
Well, funny enough, we tried AS Cardio with a dog once, right? And it worked pretty well. So you never know.
Cannot make any guarantees, but it might produce something. But if not, best to work with the support team here to look at segmentation workflows, and then look at maybe some of the other automation possibilities with scripting, perhaps. Some quick questions. Can you separate the cortical bone, trabecular bone, red marrow, and yellow marrow? I guess not on the tools we've in the off-the-shelf tools here, but with custom solutions, if we can consistently segment it and it's visible within the scan, then yes, we can build a model to predict that or do the inference on those different parts of the bone. What was the slice thickness in this demo? Just double check that one. The slice thickness for these two scans was 0.7 and 0.625. Saying that, try it on any resolution, high or low resolution. It doesn't really matter. And I think there was also a question about the can you work from higher density raw data than the DICOM 512. Yes, assuming it's a standard CT scan of those, the ones you can see on the screen here. It doesn't have to be 512 by 512. Again, maybe there's some other things like in terms of the Hounsfield unit calibration, maybe that can sometimes cause some differences, but again, best things to try it out and let us know how it goes. Maybe one for you, Karim. Is there an additional cost if we need a customized workflow?
Yes, yeah. So typically how that works for somebody who, how it typically works for us, we have a customer, they have a workflow and they want to scale up. And what we'll do is we'll do some prototype for free of cost, free of charge, where we'll have the customer send us about 10 data sets from what they're expecting to need to segment, and send us 10 data sets that are segmented and landmarked as a ground truth. We'll train a small model, and then we'll ask them to send us an 11th or 12th data set, and we'll run those through it just to show a proof of concept, just to show that it works. And then from there, we'll define a statement of work where we define all the parameters for success, what you're expecting in terms of results, and make sure everybody is on board, and we'll sign it, and that's basically your PO. So the cost of that, it varies significantly. I'd hate to even provide a window now. It just depends on what type of segmentation you're doing, what type of data, how much data, whether you're doing the segmentation, whether we're doing the segmentation, if we need a formal clinical review, things like that. There's an upfront cost to develop that, and we call that the DPP, or digital process packet. So that's just basically an executable that is dropped into Custom Modeler. So then from there, you license the software and you have your custom tool within that, and then you're off to the races from there. But yes, it's an upfront cost, and then you license the software from there. And yeah, just to add to that, to give Yale as an example, we had Dan Wisnia, he's an orthopedic surgeon, and now we're doing Custom Modeler on neuro. But basically, I just kind of planted the seed, told him, hey, we have this capability if this is of interest to you or your colleagues. And he had a colleague in the neural group and they had this application that said, hey, I think Simpleware can help with this. And this was a year or two ago. And then we talked to them, they applied for a grant, they got their funding, and now we just signed the agreement. So yeah, this is just, it's a good to plant the seed to let you know that this is available. And if you have a research project, a clinical research project, something like that, where you're going to have to process a lot of data, you can talk to us and put that in a grant, and then we can build these tools for you.
Great. I think we might just have time to take one more question. We do have quite a lot coming in. I think some of them are maybe more on some other features. So if you do have any questions about usage of anything else in the software, please do get in touch with the support team. There's links in the software or on the website for contacting support, and more than happy to work through any workflows with you or any functionality. So maybe the last question here, do you need custom imaging protocols to build the models from, or can the software intelligently interpolate between larger slice intervals? So really, I guess it depends on what you're processing day in, day out. We like to, if we're doing the custom solutions, we want to build the AI on your kind of expected incoming data. And so it's nice and representative of what you're expecting to process day in, day out. So you might have a custom imaging protocol. That's maybe more on the MRI side. And that's probably more important on the MRI side, that you need to match the protocol for the training and also for the incoming data. CT, less so. It tends to be more standard. Again, in terms of regions of interest, there's things we can do. We can accommodate that with kind of auto cropping you saw in the off-the-shelf tools. So it just depends. And interpolation between larger slice intervals, again, we can handle that during the model building. So they don't have to be a set slice spacing. It can be any range. Obviously, if you're looking at sort of a lower resolution, 0.5 millimeters perhaps, with the incoming data, then that's what you try and build the data off, and maybe throw in a few extras just for the variety. But it's kind of capturing what you would be expecting. Anything from your side?
I mean, I think for any of the custom solutions, the way to think about it is, if you have a workflow in Simpleware or any software where it's you can consistently segment it and generate models that have value to you, and you want to scale that up, we can scale that with Custom Modeler. But if you are not able to, if you have really thick slice thicknesses and you can't get things in the manual workflow, then you can't scale that up. You have to be able to define a workflow initially, and then you can scale it. You can't generate extra data, or if there's no there, you can't pull something out, or expect AI to do it if the person can't do it. There is ways AI can help, at least if it doesn't give you the exact model you have, maybe it's, if it's an 8-hour process to segment and the AI saves you 4 hours, then there's value there. So it really depends on your application. So there's always requires several conversations. It's not just here's a brochure and then you go license it. When we get into the custom area, it's definitely a lot of back and forth, and we work with you to figure out how we can help you most effectively.
I know I said last question, but there's 2 really quick ones.
Sure.
Cardiac MRI, unfortunately not at the moment. It's just for CT or CTA scans of the heart. And what's coming in the future, I guess just stay tuned. Yeah, there will be some obviously announcements.
Stay tuned. Next release is in December, so we have some new stuff coming. So stay tuned.
Yeah, I think that's wrap up there. We've come to the top of the hour now. So for myself, I want to say thanks for all the questions. It's been really interesting looking through those and answering those today. And yeah, if you've got any kind of follow-up questions, do get in touch, and we'll be happy to talk through those, whether it's on things you've seen today or just on general usage of the software. We're more than happy to talk through those. So yeah, thanks very much for your time, Karim.
Yeah, thank you, everybody. Appreciate your time. Take care. Have a happy Halloween.